Hello friends, welcome to my YouTube channel Code Paneer. Today in this video we will talk about data types in C. Basically we will have our discussion on integer in very detailed manner. And this is tutorial number 7 in the series of basics of C programming. So let's start our discussion on the data types. First, we will understand the definition of the data type, that what does data type mean and what's the purpose and what's the intuition behind having data types in the C language. So what data types does is that it specifies which type of data does the variable will store. That means if you have a variable of say any particular data type, then this ensure that, or this specifies that, oh look, variable will only store the values which belongs to that data type. Suppose we have a example of int var equals to 0. So where int is the data type for the variable whose name was var. So by specifying this, or by declaring the variable along with data type, we mean that a variable will only store the value of int only. It cannot store values of char or float or long int. So it will only store the value of int. If we mention that we are declaring a variable whose data type is int. So this was the definition of the data type. Now we will move, by moving forward we will look at what are some types of data types we have. So mainly these are the data types which we will be learning often, or which we will be using in the C language often. So first is the int, second is the char, third float, and fourth is long int. So in this video we will only focus on the integer and somewhat on the long int part. So let's start our discussion further. Before going forward, I will take a example here. So we have declared a variable along with data type. So you can see here that we have declared a variable and also initialized it, which has int data type. That means for this data type is int, which means that the variable named var, whose name is var, which is a variable, will store only integer value. By specifying this int, we have specified that, oh look, this variable whose name is var will only store the value int. It cannot store any character value, float value, or long int value. So that's why we need data types in the C language. So var stores the integer value in the binary, only zeros and ones. You can see here variable will only store the value, the integer value, which will be combination of zeros and ones. Suppose I change this value from 0 to 2, then the compiler will change the number 2 in the binary language, which will be combination of zeros and 1, and then it will allocate the memory in the RAM according to that. So moving forward, we have format specifier for integer, which is %d, and we have discussed this in the previous tutorials also. And here 0 or 1 are called bits, means 0 and 1 are called bits. We already know this. So let's talk more about bits, that what are these and why we need them. So, and we will correlate these bits with memory also. So let's start. What is bit? Bit is a basic unit for binary language. Like we have alphabets in the English language. So similarly we have a bit, which is 0 and 1 as a basic unit for this language. And bit can have only two values, 0 and 1. This is not 2, actually it is 0 here. So we'll change this value to 0. It is not 2, cut it here. It is not 2, it is actually 0. So 0 and 1, okay. Yeah. So bit can have only two values, which is 0 and 1, 0 or 1, and combination of bits form a byte. Like in some uh, we have the definition for 1 byte as equals to 8 bits, and similarly by combination of byte we have kilobytes and so on. So what does it mean? That by by combining 8 bits we can get a byte, and then again by combining some particular amount of byte, we can get a kilobyte. So that's what it means. So we have 1 byte equal to 8 bits, we have discussed just now. Now we assume that the memory is divided into rectangular cells. Now from here we will correlate this binary number or bits with the memory, and we will see that how all concepts work. So we assume for our simplicity, or it is convention that we assume the memory which we are here, memory is denoting the RAM only. So we assume that the RAM is divided into rectangular cells, and each cell corresponds to 1 byte of memory or 8 bits of memory. So here you can see that here this is RAM, or you can say that a part of memory, and it is divided into various rectangular cells, or you can say only cells, and each cell corresponds to 1 byte. That means this cell has a memory corresponding to 1 byte, or we know that 1 byte equal to 8 bits, so it can store 8 bits of memory. And now moving forward, let's see how it stores the integer value in binary language. We will be discussing more that how the binary numbers are stored in this. So let's move forward to discuss that particular topic. So let's have a closer look. Suppose we declare a variable which has int var equals to 10. This means that the value 10 has assigned to the variable var, and its data type is integer. That means it will only it will only store the integer value. Okay, it cannot store any char, float, or any other value which belongs to different data types. So what we have here is that integer uses the 4 byte. So int data type in the memory uses the 4 byte, which means var will occupy 4 byte or 32 bits of memory. So integer data type, if you will declare any variable of type int, then it will occupy 4 byte of memory in the memory or in the RAM. So the binary representation of number 10 is this. You can say that it is total of 32-bit binary representation for number 10, and by understanding it better with the help of this memory diagram, we have here, you can see that we have declared a variable whose value is 10, and the binary representation of number 10 is this. That means 32 bits, as we have discussed that this data type using 4 byte of memory. So this is 1 byte, 2 byte, 3 byte, and 4 byte, as we have discussed that each cell consumes 1 byte of memory. So integer needs 4 bytes, so we need 4 cells to store this value 10. So the compiler will first change this value in the binary representation, which will be of 32 bits, and this 8 digit will store in the first cell, this another 8 zeros will store in the second cell, this another 8 zeros will store in the third cell, and this 8 will store in the fourth cell. So that's how the binary representation of 10 will be stored in the memory blocks. I hope that you understood it better. And one thing also we need to know, that the size of the integer depends on the architecture of the computer. That means we have discussed here that the data type int will occupy 4 byte of memory in the RAM, but it varies according to the architecture of the computer. So say that someone has a computer or a laptop with different architecture than me, then it may be possible that the int data type stores or associates on or needs only 2 bytes. So in that case we need only 2 blocks to store the variable var. So what we came to know that the size of the integer depends on the architecture of the computer. That means this 4 byte is not fixed, it will vary according to the architecture of the computer. Coming to the next point, as we have discussed that it can be of 2 byte or 4 byte also. Now let's talk about different data types of integer, especially for integers and the range. So to have better understanding, let's talk about the range for different data types of integer. The different data types for integer are, first is only, which will occupy 4 byte, or we can say that it will depend on the computer architecture, but for my computer or laptop architecture it occupies 4 byte. Okay, unsigned int will also occupy 4 byte. Again, it will vary according to the computer architecture. Then another is the long int, which occupy 8 byte, even larger than this. And once one more is there, long int, which is 8 byte. It will also occupy 8 byte. We can have also a unsigned long int, like we have int here and then unsigned int. Then again we can have unsigned long int and unsigned long int, which will occupy the same 8 byte memory. So what is here unsigned? Unsigned means that it will only take non negative integers. That means it will take 0 to infinity. It will not take any negative integer in its variable value. And int, by default, it is a sign. That means it is not unsigned, it is signed. That means it can contain negative values as well as positive values, but in a fixed range. All these have a particular range of numbers which we will be able to store in the variable. We cannot store infinite number of numbers in the variable of data type int, unsigned int, long int, and long int. So it has some range which we will be seeing in the later stage of the program. So here we have range of int, as we have discussed that this all has a range, upper bound and lower bound. So range of int is from -2147483648 to 2472147483647. So this is the range for int. That means if we want to declare a variable of type int, then we will be able to store only values lying between these or up to these. Okay, uh, including the upper bound and the including the lower bound as well as the upper bound, we will be able to store in the variable. But beyond this value and this value, we will not be able to store in the int type. We need something bigger than int, which will be long int. So now talking about range for unsigned int is, as we know that int can store negative as well as positive values, but unsigned int only store the positive values along with zeros. That means non-negative values. So the general formula for this is 2k power n minus 1. Suppose we have a 4 byte of memory, as int takes 4 byte of memory. So unsigned int will take we will be able to store values between these. So this is the value of 2k power 32 minus 1. That means we know that in 1 byte we have 8 bits. So in 4 byte we have 32 bits. So to get the range for the unsigned int, we need to put the value of n as 32, because n here is the number of bits of which is occupied by the data type int. So in the case of unsigned int, it is occupying 4 byte. That means 32 bits. So the formula to get the range is from 0 to 2k power 32 minus 1, which is 429496725. Now moving further, we have a general formula for unsigned is 0 to 2k power n minus 1, as we have talked here also. And the general formula to find out the range is, you can say that this is for signed values, not for unsigned. For unsigned we have 0 to 2k power n minus 1, but in case of int, long int and long int, we have this formula. So in the case of finding the range of int, what we have done is that we have the value of n as 32. So the formula is minus 2k power n minus 1 to 2k power n minus 1 minus 1. So the value to get the range of the int, we have to put the value of n as 4 into 8, which is 32, as it is occupying 32 bits. So 2k power 31. So the range will be from minus 2k power 31 to 2k power 31 minus 1. So this is the value corresponding to minus 2k power 31. Okay, and this is 2k power 31 minus 1. So this is the general formula which we will be using to find the range for the int, long int and long int. And for finding the range for unsigned part, either it be unsigned int, unsigned long int, or unsigned long int, we will use this formula. Okay, so for long int the value will be 8 byte or 64 bits. So here we will put the value as n as 64. So what we'll get here is minus 2 k power 63 to 2 k power 63 minus 1. So this is all about the data type integer. So far we have discussed all the parts, and we have also discussed the concept and the correlation between the bits and the memory. Now let's move on to the IDE to print all these values and have a. So here we have our IDE of the previous tutorial. Now for this tutorial I will make another file which will be tutorial 7.c. So I have this file. Now I will start writing the code. Include stdio.h, then our main function. So what we will be doing here is that we will try to find out the memory occupied by the data type int in my computer architecture, as we have discussed that the number of byte occupied by the data type int differ by computer architecture. So to know the memory occupied by the int in my laptop or in my computer architecture, we will find out that how much it is occupying. So for that I will declare a variable, or no need to declare a variable, just print it like this. So printf will use a percentage lu, and we'll use a size of operator, which we'll be talking about this in later upcoming videos. So size of indicates the size of the data type. Size of operator or a function tells that how much memory is occupied by that particular data type. So here I want to know about int. Okay, first I want to know about int. So here write that the number of byte occupied by int is percentage lu, and then new line character. Okay, similarly I will again write printf the number of byte occupied by the unsigned int is again I will use the percentage lu and new line character here, and then I will use the size of operator here, function here, and I will type here unsigned int, as we wanted to know the size for unsigned. Again I will copy this, and then okay, I will copy this, and then I will, okay, it is pasted. Now I will change. I want to know the long, just now know the long int. Here just type long int. Okay, coming again. Now I will print for long int, long int is again percentage lu, long int. Okay, now let's try to print all these values and see that how much memory are they occupying in my computer architecture. Just see that everything went fine, and then return 0. Okay, just save this file and try to compile here and have the values. So compilation tutorial 7.c. So we have compiled successfully, and now moving here, running this program. You can see the output now in few seconds. So the number of byte occupied by int in my computer architecture is 5. Same for the unsigned int, it is also 4 here. And here the point should be noted that here for long int it is 4, but in many computer architecture it can be it is found to be 8. So but in my architecture it is 4, which is equal to which is same as the int, unsigned int and long int. So similarly the, but here difference came onto the long int. So long int occupies more number of bytes in the memory. That means it needs 8 byte to store the binary numbers, or yeah, that's it. So this is all about the size occupied by the data types in the memory. Okay, so that's it for this video. In the next video we will write some code to print the range of the int, unsigned int, long int and long int, and see that what are the range of values that we can store in a variable if we define the variable of the data type which involved int, unsigned int, long int and long int. So that's it for this video. I hope that you enjoyed this tutorial and also understand the concept better. If you like this video, then please like, share and subscribe the channel, and also press the bell icon for newer updates. That's it for today, and thank you and Jai Hind.